This is letter He presenting his physics final. Your hair will lose electrons, and the electrons will be transferred to the balloon. Therefore, the balloon will gain electrons. They stick together because the balloon is negatively charged while your hair is positively charged, and following the rule that opposites attract, they attract. For 1b, following the same process for both balloons will be negatively charged, and following the rule that like charges repel, so do the balloons. For 1c, electrons are the subatomic particle that is transferred from the fur to the balloon, not vice versa. Static electricity is created when things are rubbed. When things are rubbed, negative charges will be stored in electrons, and when you touch your friend in this example, this static electricity bursts out, shocking your friend. Wires, however, have a rubber insulator, which allows the negative charges to be at rest sitting on the surface of the insulator. For 2a, I drew the circuit, and since the negative end is on top and the positive end is on the bottom, and since electrons always travel from the negative to the positive, it travels clockwise. That's 2a and b. For 2c, however, we get the voltage total by adding the voltages, voltage 1 and voltage 2. And since they are equal, it's 6 plus 6, which equals to 12. For 2d, we can just simply add the formula of voltage divided by current equals resistance, and putting in the numbers, 12 divided by 2.5 equals 4.8 ohms, which is the resistance. For 3a, I drew the circuit again, which looks like this. For 3b, we have a value of 800 milliamps, which is no use to us in this current situation, so dividing 800 by 1000 gives us 0.8 amps. Then inserting the formula of V divided by current equals resistance, and putting in the numbers of 9 divided by 0.8, we have 11.25 ohms as our resistance. For 3c, we have R total equaling to 1 over R times 3. And putting that in addition form, we have this formula, which adding them together, it gives us 3.75 ohms. For 4a, we use the formula of E equals PT, P times T, and inserting the numbers, 25 times 5 gives us energy equaling to 125 watts per hour, also known as 0.125 kilowatts an hour. For 4b, I listed light, water, hydro, war title, and sound. For 4c, we bring our kilowatts per hour here times the hours, which gives us the amount of kilowatts we use, which is 0.625, and multiply that by the cost, we get 0.0125, which rounding up equals to 1 cent, or that amount of dollars. For 5a, I simply looked at this thing and realized, oh wait, we can say that the R1 and R2 are technically in the series, so we add that together, which gives us 20 ohms, and I call that ST for series total. Then we look at R3 and R4, which is in a parallel, so we add the parallel formula, 1 over R3 plus 1 over 1 over R3 plus 1 over R4, which gives us 1 over 1 over 1 5. Now, flipping this over, we get 1 times 5, which equals 5 ohms. Adding them together, we have 25 ohms. And adding the formula for current, V divided by R, we get 120 divided by 25, which equals 4.8 amperes. But wait, that is not all. That's the current through the total circuit. But we need to find the voltage drop going into resistance 3, which is the voltage total, 120, minus the current plus R1 plus R2, which is the amount of resistors that it goes through. And we have 120 minus 96 going through this calculation of multiplying, which equals 25. Now we can find the current going through resistor 3, which equals 24 divided by 10, which equals 2.4 amperes. But that's not it. We have to multiply that by 1000 because we have to find the milliamps. So multiply 1000 to 2.4, we get 2400 milliamps. For 5b, I use the same way of doing it, which is R of the series total equals R1 plus R2, which equals 20 ohms, and R parallel total equals this formula, which equals 6 2/3, or 6.7 in decimal formation. And adding them together, we have 26.7 ohms. And adding the formula of current, volt equals voltage divided by resistance, we have 120 divided by this number, which equals 4.49. And rounding that up by literal 0.1 decimal, we have 4.5 amperes, which is the current through the whole circuit.